All right, looks like we might be live. If you can hear me okay, please put a plus in the chat so I know you're here and I'm not just talking to myself in my own world. If you were here before, welcome back. Let me know whether you're new or not in the chat. Let me know if you're new. Put new if you're new, and then put returning if you're back. Maybe an N for new and an R for returning would be cool. Hi, Halika. Welcome. Thank you for joining today. Amira, welcome. Thank you for letting me know that you can hear me. That's awesome. I'm glad that you can hear me. I'm not talking to myself. Very cool. Hi, Raymond. Welcome. Nice to see you always. Olivia, welcome. Yes, Olivia, I recognized your name. R, that's right. Awesome. Wow. Amira, you're new. So excited. I mean, Olivia, Amira, both of you were in for a treat today because Olivia, you were here last time. We talked about systems of equations. Today, we're talking about forming and solving equations. And later on, that will lead to systems of equations. So this might be a more digestible lesson for you today if you found last lesson struggling at all. And Amira, super excited to have you here. Welcome. I don't know how you found me, but super excited to show you what I have planned for today. All right. You're in the right place if you're here for a free lesson on Algebra 1, my course. And this is one of the lessons in my curriculum, forming and solving equations. You can access the professionally designed workbook in the YouTube description down below. It's that first link. You can click on that, access the workbook, and the workbook will help you to follow along in today's lesson without having to copy down any of the problems. You can just focus on the learning. So this is Algebra 1, Amira. I did have a geometry lesson on Monday, and I have one coming up on Monday as well. So you can look forward to that as well if you are looking for geometry. All right. Before we get started, if you would like to copy that URL at the top of your browser and share it with a friend, a family member who you think would benefit from today's lesson, feel free to do so. Everyone is welcome. Have a good time. Learn some math. Have some fun. Solve some puzzles. And just chat it up in the chat. So let's just have a good time today. To introduce myself a little bit, I'm Eddie. I've been teaching high school and college for about 9 years now. I've private tutored every grade level from grade 6 math all the way to students preparing for graduate school. I did really well in school myself. I got A's in all my classes, got a perfect score on the SAT, and got into my dream school, UCLA. After graduating from UCLA with a bachelor's in pure mathematics, I went straight into teaching in high schools in South Los Angeles and just discovered that I love teaching math. I have a passion for mathematics, and I hope that is communicated to you tonight through this stream. My students have gotten into the top universities. They've gotten 5s on their AP exams, perfect scores on the SAT, just did really well in my math courses and later in their college careers as well. But most importantly, they had fun doing it. And that's what we're here for today. We're here to have fun. I'm here to show you that math could be fun, accessible, and effective, and make you the next generation of math geniuses. So let's get into it. I love starting my lessons out with something called an APK, accessing some prior knowledge. We like to access prior knowledge before heading into the lesson just to get our brains working again, get our gears running. Because right now it is 5 p.m. Pacific time, but those of you that are joining in from the East Coast, it is 8 p.m. So it might be a little later. You might have, food coma from dinner just now, or you might be, headed to bed right after this. So just want to get our brains activated again. So in the chat, what is the sum of the interior angles of a triangle in degrees? What is the sum of the 3 interior angles of a triangle in degrees? We may have touched upon this in pre-algebra. Maybe in like one of the really short geometry lessons, possibly. Great, BB and Dozy. Awesome. 180 is correct. I'm glad you remember that. The sum of three interior angles of a triangle is 180 degrees. Awesome. We will need this in this following slide. Great, Amira. I see you're following along as well. What is the area of a trapezoid? Now, this one might be a little tougher to remember. So let me remind you, the area of a trapezoid is not the same as just base times height, like the other quadrilaterals that we know, like squares, rectangles, parallelograms. What we actually want to do here is we want to double this trapezoid. We want to double this trapezoid. We're going to flip it and attach it to one of the sides to make it a parallelogram. So for example, I can go boom, boom, and boom. For a really rough drawing, I think I did a pretty good job. I flipped this shape and then I attached it to the other side. Now it looks like a parallelogram. From here, we notice that the length of the base, this length is B. So we have a base of A plus B and a height of still H. So we can do base times height. So of A plus B times an H. But the problem here with this expression that we just wrote down is that we just found the area of this entire thing. We have two shapes here. We only wanted the area of one of them. So we're going to divide by 2. So Mira, I see you put 1/2 base times height. That is absolutely correct. But in this case, if you just put a B, we would be only referring to this B right here. And I know you meant base, so that's great. The entire base here would be A plus B. We'll need this information for 2 slides here on out as well. All right, let's use some of this information for the following problem. Find the value of x given the following angles. So we know, as Dozy told us earlier, 3 interior angles of a triangle add up to 180 degrees. Well, we have the measure of 3 angles here, except we have the variable x in each one. So what we're going to do here is going to add all 3 of these up and set it equal to 180. So we have 2x plus 10 plus x plus 30 plus x plus 20, and all this will equal 180. Now we can combine like terms and solve for x. Pretty simple, but the idea here, the hardest part of these types of problems, the most challenging part, is forming these equations. And that's what we're talking about today. Forming the equations is tougher than actually solving the equations. Later on in this lesson, maybe solving will become a little more challenging as well, but we're taking baby steps towards those more challenging problems here. We want to focus on forming these equations correctly, because it doesn't matter if we know how to solve the equation if the equation isn't formed correctly to begin with. Amira, I see you've solved it already. Let's add all these together. So we have 2x plus x plus x. We can add all these together right now because we have a positive sign in front of all of these parentheses, so we don't have to worry about any negatives. We have 4x here. 10 plus 30 plus 20 is 60, and that is equal to 180. Amira, I'm really excited to see whether you're correct on this or not. We're going to subtract 60 from both sides. Get 120, divide by 4. Beautiful. You got it correct, Amira. That's awesome. Really excited to see how much you will grow from with this one lesson alone. I see a lot of us are joined on Instagram today as well. Welcome. Super excited. Andrew, welcome. All right, let's try the next problem. The area of a trapezoid is 10 units larger than the area of the parallelogram. That was a lot to read, so let's try that again. The area of a trapezoid is. So whenever we see is, we can equate that with an equal sign. 10 units larger than will mean plus the area of the parallelogram. So here we already have our equation set for us. This will be 10 units larger than the area of the parallelogram. So we know since the trapezoid is 10 units larger than the area of the parallelogram, we're going to add 10 units to the area of the parallelogram. So we have 10. Area of the parallelogram is going to equal the area of the trapezoid. So once we find the area of the trapezoid and area of the parallelogram, we're going to put it back into this original equation that we just formed and then solve for x. And thankfully here, we have an x in both of these shapes. We don't have any y's or z's, so we're good to go. Let's dive right on in. So the area of a parallelogram here will be equal to base times height. So we have 8 times x plus 5, and that's equal to 8x plus 40. I'm taking this step by step, not skipping any steps here because we're still in kind of the beginning phases of this lesson. Maybe we can start to skip a couple steps later on when we get more comfortable. But right now, we're still in the beginning stages. So for those of you that may already know this, that's what we're doing. We're taking this step by step, not skipping any steps just yet. In order to find the area of a trapezoid, we're going to take, like we said before, a plus b times h divided by 2. Because what we're actually doing is we're doubling this trapezoid, sticking it to the other side, and we have this full-on parallelogram, but we have to remind ourselves to divide by 2 to just get the area of the trapezoid. So we take 4x plus 3 plus the 5x plus 2, and all this will be multiplied by h, which is 4. I wrote h instead of writing 4, all over 2. Now, the parentheses could be repetitive here, but the reason I put parentheses is just to build a solid foundation for all of us to build good habits, right? Especially in pre-algebra, algebra 1, building good habits is so, so important for later on. Imagine this 5x were a negative, right? Imagine this positive 2 were a negative or anything like that. It could completely throw us off here. So that's why I use parentheses whenever possible, because you can never have enough parentheses, right? However, the other way would not be true. If you didn't have a parenthesis somewhere, it could be a crucial mistake. You could have done all the work right and still get the wrong answer. So we'll add these up. We have 4x plus 5x is 9x, plus 3 plus 2 is 5. And now we have 4 and a 2 in the denominator. We know we can cancel a common factor of 2 from both terms, meaning we can multiply this times 2. We get 18x plus 10. Now, we formed this equation before, so we don't have to think any further. All we need to do is substitute back in. The area of a trapezoid is 18x plus 10 equals 10 plus the area of the parallelogram, which is 8x plus 40. Great. And from here, we'll combine like terms. We notice that there's a 10 and a 10 on either side of the equation. So we can actually deal with that first. A lot of us, what we would have done, because we've kind of gotten used to just combining like terms on each side of an equality first, I'm going to challenge you to find these types of patterns first before having to do more work. Because if you did combine like terms first on the right side of the equality, you would have gotten 40 plus 10, which is 50, and then subtract the 10 from both sides again to get 40. Now that's repetitive. Let's think about it, right? An equality means two things on either side are completely the same. So if there are same things on either side of the equality, we can eliminate those things, right? So let's practice thinking that way as well, right? It's really important to start thinking like this from the start. So we build a solid foundation so that later on, when we do more challenging and difficult, complex concepts and skills, we're not just doing what we memorized, right? We're actually thinking about it and truly understanding the math that's going on. And that's the beauty of mathematics, right? We're going to combine the x's here. 18x minus 8x is 10x. And we have 40 on the other side. X is equal to 4. Boom, that's our answer. We found x with this with this slightly more difficult problem than we saw in our previous slide. And now we're ready to bump up a level here. Give me a plus in the chat if you're still here following along pretty good, so I know that we're good to go. If you have any questions on this problem, feel free to ask that as well. But right now, I'm just modeling these questions before we get into some practice problems where I'll give you a couple more seconds, maybe even a minute, to solve these problems out and check our answers. Give an opportunity to make mistakes, because when we fix our mistakes, that's when the true learning occurs. Great. I do see some pluses in the chat. Love that we are following along just right. Okay, let's move on to this next problem. This is a real life problem. Amelia is 15 centimeters taller than Sophia. James is double the height of Sophia. Their combined height is 3.35 meters. Find Sophia's height. Okay, let's take a look at this one. Let's go step by step. We know we're talking about height. We know that we have three people here, Amelia, Sophia, and James. We have three different people, but we are looking for Sophia's height. That's what we are looking for. Welcome, Caleb. So this first statement, we have Amelia is 15 centimeters taller than Sophia. Using the same logic from our previous problems, is equivalent to the equal sign. 15 centimeters taller than means a plus. So 15 centimeters plus Sophia's height will equal Amelia's height. So let's write that down. I'm going to write E for Amelia is equal to 15 centimeters taller than Sophia. Great. Next, James is double. So 2 times the height of Sophia. So James is equal to 2 times the height of Sophia. And their combined height is 3.35 meters. So we're adding the heights of Amelia, Sophia, and James, and all that together will equal 3.35 meters. So E plus S plus J is equal to 3.35. Now I'm going to pause here. I'm looking for S is equal to something, right? That's what I'm looking for. But can anyone tell me anything that might look a little off here? We have E is equal to 15 plus S, J is equal to 2 times S, E plus S plus J is equal to 3.35. Are we happy with this? Can we move on? Does everything make sense? In the chat. If you think we're good, say I think we're good. But if you see anything, we're starting to think a little more here now, right? We're starting to think a little more. Have we done everything correctly? Why did Eddie just stop and pause? There must be something wrong here. Trying to find what's wrong. And we're looking back through all the phrases that we see here, all the sentences, and making sure we've translated them properly into mathematical equations. I will tell you this, all the mathematical equations that we wrote here are correct. But there's one thing. If you look back at the problem and just look at the numbers, something's off here. What is the one thing that's off? And I'm going to tell you everything I wrote here is not entirely correct. There's one thing off. And it's a very simple fix, but I want you to find it. I think we good. Caleb says, I think we good. You know, the first time I saw this problem, I thought we were good too. And then I started solving it. Let's try solving it. If E is equal to 15 plus S, I'm going to plug in 15 plus S into E. Because if 15 plus S is equal to E, then this E must be 15 plus S. I notice that 2 times S is equal to J. So I'm going to plug 2 times S into this J. And let's see what happens, right? We have 15 plus S plus another S plus 2S is equal to 3.35. Let's solve. We have S plus 2S is 4S is equal to, well, 3.35 minus 15 might take us a little more time to do that, but I'll let you know what it is. It's negative 11.65. And we divide both sides by 4, we'll get negative 11.65 divided by 4. So the problem is telling us that Sophia's height is a negative, right? There's something wrong here. There's something wrong here. Ooh, Amira says we should put 15 minus an S. Amelia is 15 centimeters taller than Sophie. Then let's put numbers into here to see if we get it, right? Let's say Sophie's actually 10 centimeters tall. I mean, that means she's literally a fetus, right? A baby. But let's say Sophia is 10 centimeters tall. If Amelia is 15 centimeters taller than Sophia, that means Amelia should be 25 centimeters tall. So we are adding 15 to Sophia's height to get to Amelia. So this is okay, right? We're good. We're good there. Oh, typo. All good. I mean, if that's a typo, then you got it perfectly correct, Amira. 15 plus S plus S plus 2S. That looks great. But we still need to find the error here. This is called error analysis, and this is a great way to learn because let's say you didn't know you made an error in your work when you're checking when you're checking your work on an exam, on some practice problems, whatever it may be. It forces you to really look for what might be wrong. And in another sense, finding that Sophia's height is negative here is definitely a problem, right? If you're of negative height, that means, I don't even know what that would mean. Would that mean you're growing into the ground? You're a root, right? You're a root of a plant. You grow with in the direction of gravity. But that can't happen, right? So what is going on here? What did we miss? And now we look back and read the problem again. Let me tell you what it is, unless you can find it first before I say it. Amelia is 15 centimeters taller than Sophia, and their combined height is 3.35 meters. What's the difference between centimeters and meters? Great, Olivia. Centimeters to meters. 1 meter is equal to 100 centimeters. So what do we have to do with this 3.35? We have 3.35 meters. That will equal 335 centimeters. So we're actually going to get rid of this decimal, and we'll try it all over again. Great, Olivia. Yes, the units are different. I'm glad you found it. So we have 335. We're going to subtract 15, and we get 320. And 320 divided by 4 is 80. And now we have Sophia's height is 80 centimeters. That's really close to, I believe, must be something like between 2 and 3 feet, right? So 2 and 3 feet. How tall is that? Would that be like elementary school? Probably. I'm not too sure, but that's what Sophia's height is, 80 centimeters. That's what we got. And that makes sense. That makes way more sense than the negative number that we got before. This makes a lot more sense. Let's try another one of these problems, but this time I want you to try it as well. Now we're talking about age. Alice is 5 years older than Julian. How would you write that as a mathematical equation? Alice is 5 years older than Julian. How would you write that as an equation? Let's call A for Alice. I'll give you a little key here, a little legend. J we'll say is for Julian. Oops. It's for Julian, King Julian. And N will be what we use for Nate the Great. Alice is 5 years older than Julian. How would you write that as a mathematical equation? Given that Alice, we can use A, J for Julian. We know that is synonymous with the equal sign. And 5 years older stands for add it up. So in the chat, let me know, what would you write? Great, Caleb. Alice, A is equal to J plus 5. Let's check. A, Alice, is equal to 5 years older, 5 plus than Julian, J. Sounds great to me, right? A equals 5 plus J is the same thing as A is equal to J plus 5, right? Addition is commutative, which means that if you have two terms or any number of terms that are being added together, you can switch them around as much as you like. Any combination of those, of that sum, will be equivalent to each other. How about this next one? Nate is 3 times as old as Julian. Don't be afraid to make a mistake in the chat. Just, what you're thinking, I want you to write it down, send it in the chat. If you make a mistake, you fix it, it sticks way better, right? It's something like it sticks 10 times better or something like that, according to brain research. If you're constantly getting things right, the chances you make a mistake in the future just becomes higher. But if you make your mistakes now, then later on with the practice problems that you get after every lesson, you'll be more confident, right? Just make that mistake. Why not? Just try something, right? Nate is 3 times as old as Julian. How would we write this one? Nate is 3 times as old as King Julian. Great. I see Caleb's response in the chat. Amira, Olivia, anyone else in the chat, don't be shy. What did y'all get? NEQ3J. Okay, looks like Caleb and Amira agree. Does everyone else agree? Nate stands for N is synonymous with the equal sign. 3 times as old as Julian. So we have 3 times J. And that looks amazing. Great stuff, y'all. Now, their combined age is 75 years. How would we write that down as an equation? Their combined age is 75 years. Don't get confused here. We only have 3 people here, right? Not 4. I know you see 4 names, but Julian appears twice. So we only want to write 3 names here, or we only have 3 names here is what I'm trying to say. Jiyoung, great. I see you got it correct as well. Awesome work. So we have Alice, Julian, and Nate. So we have A plus J plus N, and that's equal to 75. Awesome. How old is Nate? So we're looking for N. What does N equal, right? This is the variable that we are looking for. We're looking for Nate's age. So we don't care about what J is or what A is. We want everything to be in terms of N. So we want, what does J equal and what does A equal in terms of N? Well, thankfully, J and N are already in one of these equations. So we can isolate J by dividing both sides by 3. And when we're dividing by 3, that's the same thing as multiplying by a third. So we know J is equal, let me write it up here actually. J is equal to 1/3 of N. So that'll become 1/3 N. The N comes straight down, and we still have equal to 75. Now we're looking for what A is equal to. A plus J plus N equals 75. Great, Amira. So A is equal to J plus 5. Now we know J, if I were to color code this here, J is equal to 1/3 N. Here's a J, and here's the A that I want to plug into. Let me use a different color. Let's use red. A is what I want right here. So if J is equal to 1/3 N, A will equal 1/3 N plus 5. Don't forget that plus 5. Very common mistake that students in the past have made. They say, oh, A is equal to J plus 5. They'll color code this and forget to copy down the plus 5 after substituting the 1/3 N in for J. So A is equal to 1/3 N plus 5. Let's box that in red as well, just to color code exactly what we're doing here. And we can substitute 1/3 N plus 5 into this A. So we have 1/3 N plus 5, and we're still adding all the way across. Now we have a beautiful equation with only one variable, and that is the variable that we're looking for. So now we are happy. This is what forming equations is all about. From here, all we're doing is solving. Solving is the easy part. Anyone can solve. But forming these equations is what we're focusing on today before we reinforce the skill of solving these equations. So let's check what this will actually equal. We have 1/3 of N plus another 1/3 of N. That's 2/3 of N plus 1/2 of N. So 2/3 of something plus a whole of something. we need a common denominator. The common denominator here would be 3. So we have 2 plus 3 all over a common denominator of 3. That's how we get 5/3 of n is equal to, well, this 5 is the only number on the left side of the equality. I'm going to subtract 5 from both sides. So 75 minus 5 is 70. Now, from here, what would you do in the chat? What would you do to solve for n? What's the very next step here that you would take? 5/3 times n is equal to 70. What is the next step you would take here? I would say if you are working with rote memorization here and just order of operations, the first thing you would probably do is divide by whatever's in front of the n, right? You divide both sides by 5/3, but do you even know what that means, to divide by 5/3, right? That's like, what does that even mean? So instead, what we can do, instead of dividing both sides by 5/3, what's another way we can write that? Dividing by any number, if I were to give you a hint, dividing by any number is the same thing as multiplying by its reciprocal. There's a math term. Reciprocal meaning two terms multiplied together equaling 1. And those two terms are called reciprocals. What would you do here? What would be this very next step? Ooh, okay, Caleb. Multiply both sides by 5/3. Let's try that. If we were to multiply both sides by 5/3, remember what we're trying to do here is we're trying to get to n. When we multiply fractions, we multiply across the numerator, across the denominator. So 5 times 5 is 25. We have 3 times 3 is 9. And on the right side, 70 times 5 is 350. And the 3 in the denominator, 70 is basically 70 over 1. So we don't have to worry about that. Did we get any closer to getting n by itself? I'm not too sure if we did. We now have 25 over 9 in front of the n instead of a 5/3. So this might not be the way, but let's see how we can change this to make sure it is the way. Ooh, Amira and Chiyoung helping us out here. We multiplied by 5/3, but what if we multiplied by the flipped version of that? What if we multiply both sides by 3/5 instead of 5/3? Let's try that. So if we multiply it across, we get 3 times 5 over 5 times 3. Well, that's 15 over 15. Look at that. 15 and 15 cancel out, leaving just 1. Boom. There's the n that we wanted by itself. Now we'll multiply across here. We have 7 times 3 all over 5. But in other words, we can also do 70 divided by 5 first. Cancel out a common factor of 5. 5 goes into 17 14 times. Times the 3 will give us 42. So Nate is 42 years old. Great teamwork in the chat. I'm so glad we're participating here. Again, don't be afraid to make mistakes, because the brain research heavily supports that when you make a mistake and you fix that mistake, that's when it really sticks, right? That's when true learning occurs. So do not be afraid to make any mistakes. Awesome stuff. Yes, Amira, that's correct. A number of times it's reciprocal, they will cancel into 1. Great. I love how we're summarizing the work as well. That's how we know we're learning, right? If you're able to teach something to someone else, that's when you truly know what you're doing. Amazing stuff. Great, Reyes. Let's try this next one. The length of a rectangular field is 4 times its width. The length of a rectangular field is 4 times its width. Instead of reading this over and over again, right? That often happens on exams. You'll read something and you'll just keep reading it over and over again to see if you'll finally get it after the 6th or 7th time reading it. How about we annotate right away? Let's annotate this right away. The length of a rectangular field. All right. Well, length starts with L. I know I'm going to be working with a rectangle. So let's call this L. Is synonymous with the equal sign 4 times. That's 4 times its width, W. So here's the width of a rectangular field and the length of a rectangular field. What this first sentence is telling us is that the length is 4 times the width. So immediately what I do in my diagram is I cross out the X or the L and I'll put 4W instead. Because oftentimes when we're working with these types of problems, we like to put everything in terms of just one variable. If we have multiple variables on our diagram or on our paper, that's where things start to get lost. So we want to do the work when we can right away. The total perimeter of the field is 60 meters. Ooh, new word, perimeter. What does perimeter mean? Can anyone tell us in the chat? What does perimeter mean? Perimeter. Well, I see the word meter in there. Meter is usually used to describe some type of distance. What does peri mean? What does that prefix mean? Peri. I actually don't know. I'm going to search that up. Prefix peri meaning. It means enclosing, around, about, or surrounding. Ooh, okay. It's a Greek prefix. Learn something new today. Just together. Peri means surrounding or around. We know meter is used to describe distance. So maybe the surrounding distance or the distance around everything, maybe that's what we're talking about. Seems right, right? And look at us in the chat, measuring all 4 sides, maybe. 4 times W plus W equals 60, distance around the shape, sum of all 4 sides. Beautiful work, beautiful work. So perimeter often is defined first using rectangles and squares in schools. So that's where sum of all 4 sides comes from, or sum of all sides comes from. But sometimes later on, or actually later on, not sometimes, later on you will learn that there are shapes with 1 or 0 sides, right? Like the circle. Is it all just one side or is it 0 sides? So it's just the surrounding distance, right? A distance around a shape. All of them combined is the perimeter. Excuse me. So if the length of this rectangle is 4W, then the other side must also be 4W, and the width should remain W. So we're going to add all these up together. So we have 4W plus 4W plus a W plus another W, and that will equal 60 meters. Don't forget, we're going to use these units at the end of the problem. So 4W plus 4W plus W plus W is 10W. And so W is equal to 6 meters. If W is equal to 6 meters, are we done with this problem? Have we completed this problem? We're good. We're good to go. We can go to the next problem. It's like the way I'm asking it is basically giving it away that we're not done with this problem. But exactly, Chiang, right? W equals 6 meters. We are looking for the area of the field, right? The area of the field, it looks like Amira got it already, will be base times height or length times width. So we'll have 6 meters is equal to 24 meters. So if we have the area of the field, we'll have 6 times 24. And each of these are in terms of meters. So meters times meters will give us meters squared. If a problem gives you units of measure, you must include the correct units of measure in your final answer as well. Our final answer here is 144 meters squared, and we're good to go. Now, again, the hardest part of this problem, actually, there are 2 challenging parts for this problem. I'd say the first challenging part is creating this diagram and forming this equation. That's probably the hardest part. Now, the second hardest part is reading the entire question, not forgetting that we're not done at W equals 6 meters, and we actually have to find the area of the field in order to complete our problem. Okay. Oh, Jiyoung, I love that you made that mistake. 6 times 4, right? You saw this 4, and you did 6 times, or maybe you're just doing to find the length 24 meters, and that's amazing. But if you did make the mistake that I think you did, where you did 6 meters times this 4 to get 24 meters squared, that is also a very common mistake that students will make, right? And since you made that mistake right now, you said, oops. So I'm assuming that you've corrected yourself. Um, there's the probability that you'll make that mistake again is significantly lower now. Yeah, amazing stuff. I love that you shared that as well. Awesome. Okay, let's try this next one. Yes, everybody makes mistakes. I don't know if you guys know that song, but it's the lyrics to one song. All right, anyway, in 5 years, I digress, I will be twice as old as I was 15 years ago. In 5 years, I will be twice as old as I was 15 years ago. How old am I now? Ooh, this one's a bit trickier. Let's solve this one together, and I'll have you participate in the next one. So pay attention here. I'm going to model this problem. In 5 years. All right, so I'm my age right now. And I'm talking about in 5 years. In 5 years. So that means whatever age I am right now, let's call that X. In 5 years, so add 5 to how old I am right now, I will be. Will be means equal to twice as old, so 2 times as old as I was 15 years ago. 15 years ago, I was X minus 15 years old. So if I'm twice as old as how old I was 15 years ago, I have to multiply 2 times an X minus 15, just like that. Difficult problem if you're not, splitting this question apart into pieces, right? We first worked with in 5 years. That's where we got the X plus 5. I will be twice as old. That's where we got the 2 times. And this is bad notation. So I'm actually going to color code this one. Twice as old is the same as 2 times as I was 15 years ago is this entire thing. Now let's solve. X plus 5 will equal 2 times X minus 15. So we have 2X minus 30. And now I'm going to solve for X. Now here is something that many teachers don't teach as well. I like to keep my coefficients for X, or whatever variable I'm solving for, I like to keep them positive. I like working with positive numbers because when we work with negative numbers, although it is important to get comfortable using negative numbers, at least when we are first starting, when we start working with negative numbers, the probability that you will make a careless mistake skyrockets. So we want to work with positive numbers when we can. And what I mean by this is that I noticed that 2x is larger than x. So instead of always moving all the variables to the left side of the equation, I'm actually going to subtract the x on the left side of the equation from both sides. And some may say, oh, you have to become more comfortable with negative numbers. But I would argue you have to become more comfortable with working with both sides of the equation, right? You can't just get stuck on just working and just isolating the left side of the equation. An equation means that both sides of the equation mean the same thing, right? So you can isolate either side. It will still mean the same thing, right? I remember one teacher a long time ago, I put the answer as like 3 equals x or something. And they took off points because I didn't write x equals 3. I was like, wait, that's the same thing. But I hope none of your teachers do that. But again, flexibility, right? We like to be flexible and adjust. So we subtract x from both sides. 2x minus x is x. When I move this negative 3 to the other side of the equality, it changes signs to positive 30. Why that happens is an equal sign is the same thing as a 0 on a number line. You can think about it like that. An equal sign is the same thing as a 0 on a number line. So whenever numbers switch from one side to the other, they flip signs. So you have 30 plus 5 is 35, and that's how old I am now. Not really, but for the sake of this problem, let's say that's how old I am now. Now, this next problem, and again, x is equal to 35, so I need to write my units of measure, 35 years old. Okay, let's try the next problem. Try this one. Try to put in the chat what you get for this one. In 7 years, I will be 4 times as old as I was 8 years ago. How would you write this as a mathematical equation if this were on an exam? We tried a problem just like this right now. So it could be a little bit of just substitution from the previous problem, but still, as you're writing it down, try to think about what's really going on, right? Focus on the understanding, not just knowing how to do one type of problem. And that's what I like to focus on in my lessons. I'm not just trying to teach you how to solve as many types of problems as possible. I'm trying to teach you, no matter what type of problem you're given, you are able to adjust by searching for understanding of the problem and being able to solve any type of problem. In 7 years, I will be 4 times. Okay, there's a 4 times. Great, Caleb. I love that we're, writing what we know. That's a great start. Caleb, you bring up a really good point here. I'm so glad that you mentioned that. Thank you for being brave and sharing that. 4 times. Oftentimes, we can't just picture everything all at once. We're going to take it piece by piece. Okay, we're going to take it piece by piece, and that's perfect. Looks like Chiyoung gave us the answer here. In 7 years means x plus 7. X being how old I am now. How old am I now? Let's call that x. In 7 years means 7 years ahead. So we go x plus 7 is equal to 4 times as old as I was 8 years ago. So 8 years ago, I was x minus 8 years old, because right now I'm x years old. 8 years ago will be x minus 8. Forming this equation is much, much more challenging than solving this equation, right? Once we have the equation, super easy, right? The forming part is the challenging part, and that's what we're focusing on today, right? Or that's what we've been focused on today. So x plus 7 is equal to 4x minus 32. Don't forget that we must distribute the coefficient of any parentheses to all terms within the parentheses. So if x is, I'm going to combine like terms here. 4x is greater than x, so I'm going to subtract x from both sides to get 3x. I'm going to move this negative 32 to the other side of the equal sign to get positive 32. 32 plus 7 is 39. And so x is equal to 13. How old am I now? 13 years old. I went 22 years back in time from 35 to get to 13 years old, which is, I might guess, how old some of you are in the chat. 13, 14, maybe 15, maybe 11, maybe 12, around there. That's why I wanted to create this practice problem. All right, the last problem we're going to do together today, let's take a look at this one. The sum of two numbers, x and y, is 45. Let me know in the chat, what would you write down for that mathematical equation? The sum of two numbers, x and y, is 45. What would you write for that? In the chat, let me know. I know Amira's still here, Chiyoung, Caleb, Olivia, Reyes, Khan. What would you write as x plus y is 45? If you haven't chatted yet, feel free. This is your opportunity before we end our lesson today. This is our last example before I have something really special to share with you. The sum of two numbers, x and y, is 45. How would you write that down as a mathematical equation? And I know typing out math could be a little difficult, so that's why it's taking a little more time in the chat, but there they are. Olivia, Caleb, awesome work. X plus y is equal to 45. Amazing. The sum of two numbers. Sum, you might have forgotten, but sum means any amount and any number of terms added together. So x plus y is equal to 45. Is, again, synonymous with the equal sign. So perfect work there. And the difference between them is 15. But now here's the dilemma. How do we know to write x minus y or y minus x, right? How do we know? Well, this next sentence tells us. Given that x is greater than y. So x is greater than y. So which one should it be? Should we be writing x minus y or y minus x when we know the difference between them is a positive 15? Which one would be correct? Number 1 or number 2? Which one should we use in the chat? I know that x is greater than y, and the difference between x and y is 15, a positive 15. In that case, which one should we use? X minus y or y minus x? Distressed. I know. So much thinking, right? This is the most challenging problem we face today. But what should we use? Number 1 or number 2? Which one makes more sense? I'll try to use telepathy to send you the answer. X is greater than y. Let's think about that. If x is greater than y, that means x is the bigger number. If we subtract a smaller number from a bigger number, we'll always get a positive number. But if we subtract a bigger number from a smaller number, we'll be getting a negative number. So in this case, autocorrect. Oh, great. Number 1 is correct. Yes, because we have the bigger number minus the smaller number giving us this positive number. So we have x minus y is equal to 15. And guess what we can do? We can actually just add straight down. And this will come up in a future lesson on systems of equations. For those of you that are returning and have been here with me before in one of these free lessons, you know that elimination or substitution is what we can use for the system of equations. But if we add straight down, x plus x is 2x. Great, Nikki. I see you on Instagram as well. I see you. 45 plus 15 is 60. And I didn't write the y's because notice, positive y minus a y is 0. So x is equal to 30 here. Are we done? Are we done? I can call it, right? We're done. X is equal to 30. We are finito with this problem, with the lesson. Just kidding. We have to find y, right? We have to find y. If x is equal to 30, then what will y be? Well, we can plug in x is equal to 30 into either this x or this x. It'll give us the same thing. 30 plus what number equals 45? Y is equal to 15. Well, 30 minus 15 is also equal to 15. Great. That's how we know we have the answer. We're good to go now. Find y. We have found y. All right. If you're still here and you enjoyed this lesson, put a plus in the chat for me, or a W for a W lesson, for a W stream, for W participants, for WU. Give yourself a W. And if your parents are nearby or guardians are nearby, call them over because I have something really special to share with you. Let's get into it. Our lesson may be ending, but your progress doesn't have to. My Space Algebra 1 full year course with me starts on October 6th, so less than 3 weeks from now. Each course includes 2 of these types of live lessons every week, and every lesson is video recorded. So if a family situation ever occurs or you have an event going on and you can't make it to that lesson, no worries. All the lessons are recorded so you can review. Let's say your teacher is going over something I already went over maybe 2 months before, and you want a head start on it, or you've already learned it, but you want to review, you can always go back to those lessons as well. Every lesson will come with a professionally designed workbook so that you can focus on the learning and not stress about writing everything down. All the problems will be there for you on the workbook so that you can focus on the learning. After every lesson, you're not getting it today, but after every lesson in my course, you will get practice with exam-style questions that we create to the level of exams based on the lesson that you just learned to, again, master and practice these concepts and skills. And I don't leave you hanging. I'll be making detailed video solutions on every single problem you practice so that it's basically like another lesson, right, within a lesson. But how much is it? For context, when I used to be a private tutor, how much do you think I used to charge per hour? And to give you a little story while you guess in the chat, because there's a little bit of lag between me and the chat. That's why it takes me a couple seconds to reply to your chat responses. I used to volunteer tutor in high school. So basically pro bono, meaning for the public good. And then when I got into UCLA and needed some, um, money to eat on the side, I used to tutor for about $25 to $30 an hour. So still very affordable, but not as effective, right? As a college student, what do I really know, right? What do I know about what teachers are teaching in school? All I know is like homework help. Maybe I can give some practice problems, things like that. And after a few years of teaching, right? Teaching high schools, teaching colleges, teaching graduate students, it's not me that raised the prices. It's more so the families were like, "Oh, you need to be paid more, right? You deserve more." And so that's how I got to some very good guesses in the chat. Caleb, I see you 30, 40. Chiyoung said money sign. Chiyoung's been here before. But I used to charge a minimum of $100 per hour and topped off at around 200. Nikki, I see you with the 50 on Instagram. And that's the thing, right? With private tutoring, families have to choose between what works and what they can afford. Effectiveness versus affordability, you can never get both, right? If they're affordable, then not as effective. Maybe just homework help, and you don't even know if they're actually getting the help. If, right, basically, right, basically put, affordability versus effectiveness, you can't get both, and that's why we created My Ed Space. All of this for just $99 a month. Every month, we hold about 7 to 8 lessons, meaning that with $99 a month, that's less than $15 per lesson, per hour, per practice set, per video solution, per everything, right? And why stop there? If you pay up front for the annual package for all 60 lessons running from October 6th all the way to June 5th, you get a 20% additional discount. And to protect you from any risks, we provide a 30-day risk-free full refund guarantee. And this is because I'm confident once you start, you won't want to leave. You're going to want to continue learning with me. If that's not the case, though, you can have this in mind. You have a 30-day risk-free full refund guarantee. So the first month. First come, first serve. This is a limited time offer. So if you are interested, go ahead and text code word START to my number, 512-900-1283. Or you can screenshot this, send it to your parents, say you really want to join my course, want to get ahead, you're having fun learning math finally. You can scan the QR code. It'll automatically prompt you to send the code word START to this number, just in case you're worried that you're not going to type my number incorrectly in your iMessage or SMS text, whatever it may be. But that is it for today, y'all. Thank you for joining on in. Again, code word START to 512-900-1283. Really happy with how today's lesson went. Love the participation on all the platforms. And I hope to speak to you soon. Special shout outs, Nikki, Chiyoung, Caleb. We had Reyes. We had Olivia. We had Amira. I hope I didn't miss him. Dozy, BB, Raymond, whole bunch of folks. We had Andrew earlier as well. Thank you for today's stream. Have a great rest of your evening, and I hope to speak with you